Hey, we've spent the last century using two different rulebooks to explain how the universe works. On one side, we have general relativity, which explains the big stuff like stars, galaxies, and gravity. On the other, we have quantum mechanics, which handles the tiny stuff like atoms and subatomic particles. Both work perfectly in their own lanes, but when you try to use them together, the math literally breaks. This is the search for quantum gravity, the ultimate theory of everything. To understand the clash, you have to look at how these two theories view the world. Einstein's general relativity sees space as a smooth, flexible fabric. Think of a silk sheet that curves beautifully under the weight of a bowling ball. It's predictable, elegant, and continuous. But quantum mechanics is anything but smooth. It's chunky. Everything is broken down into discrete bits called quanta. If you zoom in far enough on the quantum level, the universe becomes a chaotic, blurry mess of probability, where things don't have certain positions, they just might be there. The clash happens at the smallest possible scale, the Planck length. If you try to zoom in to the smooth fabric of Einstein's spacetime using the rules of quantum mechanics, the fabric doesn't just curve, it shreds. It becomes something scientists call quantum foam. At this scale, time and space as we know them stop making sense. The math starts spitting out infinity as an answer, which in physics is a polite way of saying we have no idea what's happening. We need a way to merge these two, and physicists are coming up with some truly wild solutions. The most famous is string theory. It suggests that if you zoom in past the electrons and quarks, everything in the universe is actually made of tiny vibrating loops of string. Different vibrations create different particles, just like different vibrations on a guitar string create different notes. But for the math to work, string theory requires at least 10 dimensions, most of which are curled up so small we can't see them. Then there's loop quantum gravity. Instead of strings, this theory suggests that space itself is made of discrete loops woven together. Imagine a piece of chainmail armor. From far away, it looks like smooth fabric, but up close, it's made of individual interconnected rings. In this version, you can't divide space forever. There is a smallest possible atom of space itself. Why does this matter? Because there are two places in the universe where we have to use both theories at once, black holes and the Big Bang. Both involve a massive amount of stuff, relativity, packed into a tiny subatomic space, quantum. Until we solve quantum gravity, the very beginning of our universe and the center of black holes will remain a total mystery. So, we are currently living in a time where our two best descriptions of reality are fundamentally at war with each other. Solving this clash would be the greatest scientific achievement in human history. Pretty wild, right?